Think about the last thing you Googled. It took, what, half a second? You got your answer and you moved on. But behind that one simple click is a scale of data that is honestly hard to wrap your head around. Every single second, Google handles over 100,000 searches. Toss in YouTube uploads, Gmail, and Maps, and we're talking about petabytes of data flooding their systems every few minutes. If you tried to save just one day of Google's traffic onto standard hard drives, you'd need a stack of them taller than Mount Everest. And here's the kicker: it can never crash. If Google goes down for even 5 minutes, the modern world basically grinds to a halt. So how does one company handle all of humanity's data without the whole internet catching fire? It turns out Google had to completely reinvent how computers work. To understand how Google manages this today, we have to go back to the late 1990s, when Google was just two guys in a garage trying to catalog the entire web. To do that, they had to build an index. Think of the internet back then like a massive, chaotic library with millions of books, but no organization. Google's job was to create the ultimate index at the back of the book. They sent out automated software bots, called crawlers, to constantly scan the web. A crawler would land on a web page, read all the words on it, look at the links, and then follow those links to the next page. As these crawlers traveled the web, Google built a giant digital catalog. If a page talked about baking bread, Google's index would record that exact web page under the keyword bread. So when a user typed bread into Google, the system didn't actually search the live internet in real time. It just flipped open its pre-made catalog, found the word, and showed you the pages it had already saved. In the beginning, this catalog lived on just a few custom-built servers made out of cheap, off-the-shelf parts. Some of them were even cased in Lego bricks because the founders were on a budget. But as the internet started exploding in the early 2000s, Google went from indexing a few million web pages to billions, and that is where they hit a massive roadblock. The data was growing too fast for normal computers to handle. If you keep a massive index on standard machines, you run into two major problems. First, a single computer can only search through its files so fast. When millions of people are searching at the same time, the computer bottlenecks. Second, and worse, cheap computers break. When you have thousands of them running 24/7, they don't just fail occasionally, they fail every single day. Google realized that if they kept using regular setups, their index would constantly be losing data as computers crashed around them. They were running out of space, running out of speed, and the hardware was literally dying. By 2003, Google's engineering team realized they couldn't buy their way out of this problem with expensive, specialized hardware. So they decided to do something radical. Accept that hardware will break and fix it using incredibly clever software instead. Two foundational engineers stepped up to design this new blueprint: Sanjay Ghemawat and Jeff Dean. Their first massive breakthrough in 2003 was the Google File System, or GFS. Instead of saving a giant file onto one computer, GFS took that file, chopped it into smaller chunks, and scattered those chunks across thousands of cheap computers. And here was the genius part. It automatically made multiple copies of every single chunk. If one computer suddenly died, the system didn't panic. It just seamlessly pulled the backup copy from another machine. As Sanjay Ghemawat later put it, the system must tolerate constant component failures without human intervention. GFS was a revolution for storing the data, but Google quickly ran into their next hurdle. They had all these chunks scattered across thousands of machines, but they didn't have a fast way to actually search through them and combine the pieces into a single search result. To solve that, Jeff Dean and Sanjay introduced MapReduce in 2004. Instead of asking one central computer to search a massive database, MapReduce took a search query and split it up among thousands of cheap computers at the exact same time. Each computer searched its own tiny chunk of data simultaneously, and then they all sent their mini answers back to a central point to be combined. Jeff Dean explained the philosophy simply. It's like having 1,000 people read different pages of a book to find a specific word, rather than having one person read the whole book alone. With GFS and MapReduce combined, Google stopped viewing hardware failure as a disaster. It was just a normal Tuesday. They had successfully built a giant, indestructible supercomputer out of cheap, disposable parts. By 2005, Google had figured out how to store massive files and how to search them, but they hit yet another wall. Some of Google's growing services, like the brand new Google Maps or historical data for Google Analytics, didn't fit neatly into raw file chunks. This data was highly structured, constantly updating, and needed to be accessed instantly. Traditional databases back then were relational. Think of them like a cluster of separate spreadsheets, one for users, one for addresses, one for purchases, all tied together by strict relationships. To find an answer, the computer has to look at table A, find a matching ID in table B, and stitch them together. This works great on a single computer, but if you try to split those connected spreadsheets across thousands of different machines, the system completely bottlenecks trying to stitch the data back together over a network. So Google's engineers threw out the old playbook and built Bigtable. Instead of a web of connected tables, Bigtable is essentially one monstrously huge single spreadsheet. Technically speaking, it's a sparse, distributed, multidimensional sorted map. Here is the big difference in how they store data. Traditional databases are usually row-oriented, meaning they store an entire row of data together on the disk. Bigtable, however, is column-oriented. It groups data by columns. Why does that matter? Imagine a database tracking billions of users. If you only want to look up everyone's last active time, a traditional database has to read through every single piece of user data, names, emails, passwords, just to grab that one metric. Bigtable can jump straight to the last active column family on the disk, skipping petabytes of unrelated data entirely. It was also designed to be incredibly flexible. If Google Analytics needed to add a new tracking metric for millions of websites, Bigtable didn't require reshaping a rigid database schema. It could just dynamically add a new column on the fly without shutting down or slowing down the system. As Google's data requirements grew even more colossal, their foundational storage evolved too. The original Google file system was eventually replaced by an upgraded next-generation storage system called Colossus, which allowed Google to handle even tighter latency and scale up to automatically manage exabytes of data. With Colossus storing the data, MapReduce crunching it, and Bigtable organizing it, Google had built a holy trinity of data infrastructure. In fact, these three technologies were so revolutionary that Google published white papers about them. Because Google's internal code was secret, engineers outside the company read these papers and used the ideas to build open-source clones. GFS and MapReduce became Hadoop, and Bigtable inspired databases like Cassandra and HBase. Unwittingly, Google had just laid the foundation for the entire modern big data industry. Today, we take the speed of the internet completely for granted. We just expect videos to play instantly, maps to reroute us in real time, and search bars to know what we want before we even finish typing. But none of this would be possible if Google hadn't hit that massive wall back in the early days. By realizing that hardware would always fail and choosing to solve their data crisis with brilliant software architecture, they didn't just save their own search engine. They basically wrote the playbook that the entire modern internet runs on today. And that is how a couple of guys in a garage ended up building a system that handles pretty much all of human knowledge without breaking a sweat.